You switched to Linux because you were done being watched. You were done with Windows sending telemetry to Microsoft servers in the middle of the night. You were done with every click, every search, every file you opened being logged, analyzed, and fed into a data machine you never consented to and could never fully escape. You chose Linux because Linux was supposed to be different. Linux was supposed to be the operating system built by the community for the community. The one place in the computing world where your machine actually belonged to you and not to a corporation sitting thousands of miles away with its hand in your data. And for a long time, that belief was justified. For a long time, Linux really was that operating system. But something has changed. Something has shifted in the Linux ecosystem in ways that most users have not noticed, most distributions have not loudly disclosed, and most of the mainstream technology press has not covered with the seriousness it deserves. Linux is tracking you now, not in the same way Windows tracks you, not with the same scope or the same corporate intent, but it is happening, it is real, it is spreading across more distributions and more projects than most Linux users currently realize, and you need to know exactly what is going on, exactly which distributions and projects are doing it, exactly what data is being collected, and exactly what you can do about it right now. The story of how Linux went from being the privacy-respecting alternative to becoming a platform where tracking and telemetry are increasingly normalized is not a story of sudden betrayal. It is a story of gradual drift, of well-intentioned decisions made by developers and organizations that genuinely wanted to improve their software, of corporate influence entering the open source ecosystem with money and resources that the community needed, but that came attached to priorities and expectations that did not always align with user privacy. Understanding how this happened requires going back to the point where the drift began, because the drift did not start with malicious intent, and it did not start overnight. It started with a problem that every software developer faces and that open source projects face in a particularly acute form. How do you know if your software is actually working for the people using it if you cannot see how they are using it? This is the question that motivated the first generation of telemetry additions to Linux distributions, and it is a question worth taking seriously because it reflects a genuine challenge in software development. When a proprietary software company wants to understand how its product is being used, it has the option of deploying analytics quietly and comprehensively without asking for user consent, because the terms of service that users click through without reading grant that permission. When an open source distribution wants the same information, the ethical and philosophical commitments of the open source community create pressure to ask for consent, to be transparent about what is collected, and to give users meaningful control over participation. The distributions that took this pressure seriously and built genuine opt-in systems with clear disclosure deserve credit for trying to solve the problem ethically. The distributions that took shortcuts, that implemented opt-out systems rather than opt-in, that disclosed their data collection and release notes that most users never read, or that gradually expanded the scope of their collection beyond what was originally disclosed, are the ones that created the privacy problem that Linux users are now dealing with. Ubuntu was the first major Linux distribution to introduce telemetry in a way that generated significant community controversy, and the story of Ubuntu's data collection practices is important to understand in detail because it established a template that other distributions have followed in modified forms. Canonical, the company behind Ubuntu, introduced a system reporting feature in Ubuntu 18.04 that collected information about hardware configurations, installed packages and system settings, and sent that information to Canonical's servers. The stated purpose was to help Canonical make better decisions about which hardware to prioritize for driver support, which packages to include by default, and where to focus development resources. These are genuinely useful things to know, and the argument that collecting this information improves the distribution for everyone is not dishonest. But the implementation details matter enormously when evaluating whether a telemetry system respects user privacy, and Ubuntu's implementation had details that privacy-conscious users found problematic. The Ubuntu system reporting was implemented as an opt-out rather than opt-in system, meaning that data collection began by default unless users actively chose to disable it during installation. The installation interface presented the option to disable reporting, but the framing of that interface, the language used, and the prominence of the opt-out option were all designed in ways that made opting out feel like declining something helpful rather than asserting a privacy right. Most users, particularly those who were new to Linux and who were proceeding through the installation process quickly, never noticed the opt-out option or did not understand its implications clearly enough to make an informed choice. The result was that data was collected from the majority of Ubuntu installations, even though a significant portion of those users would have chosen not to share data if the choice had been presented clearly and as an opt-in rather than opt-out decision. The data collected by Ubuntu's telemetry system expanded over time in ways that the original disclosure did not fully anticipate. What began as hardware and package information grew to include information about which applications were installed, how frequently the system was used, what desktop environment configurations users had chosen, and other behavioral signals that go beyond the hardware compatibility use case that originally justified the collection. This expansion is a pattern that privacy researchers call scope creep, and it is one of the most common ways that data collection programs that begin with defensible purposes end up collecting information that goes well beyond what users would consent to if asked clearly. Each individual expansion of scope may seem minor in isolation. The cumulative effect is a substantially more invasive data collection program than users originally agreed to. Fedora, Red Hat's community Linux distribution, has its own telemetry story that is different from Ubuntu's in its implementation, but raises similar questions for privacy-conscious users. Fedora introduced a counting system that reports when a new Fedora installation occurs and when packages are updated, providing the distribution with information about the size and growth of its user base. The Fedora community debated this system extensively before implementing it, and the implementation reflects more careful attention to privacy than Ubuntu's initial approach. The data collected is less granular, the purpose is more narrowly defined, and the community process that approved the system was more transparent. But the system exists. It is enabled by default. And users who did not know to look for it or did not understand what it was collecting when they set up their Fedora system are participating in data collection without meaningful awareness of that participation. The more recent and more concerning development in Fedora's telemetry story is the proposal and partial implementation of more comprehensive metrics collection that would capture information about installed applications, hardware configurations, and usage patterns in ways that go significantly beyond the simple counting system that was originally implemented. These proposals have generated debate within the Fedora community, with privacy advocates pushing back against expansions of scope and developers arguing for the utility of more comprehensive data in guiding distribution decisions. The outcome of these debates is not fully settled, and the direction of travel, toward more collection rather than less, is the trend that Linux users need to monitor carefully because it reflects the pressures that every distribution faces as corporate influence and development resource requirements push toward more data collection as a way of demonstrating value and guiding engineering decisions. The Pop! OS distribution from System 76, which has gained significant popularity among Linux users who want a polished desktop experience with strong hardware compatibility, added telemetry features that its user base was not uniformly aware of or prepared for. System 76 is a hardware company as well as a distribution maintainer, which means it has specific commercial interests in understanding how its software performs on its hardware and how users interact with the desktop environment it has developed. The telemetry it added reflects those commercial interests, collecting information about hardware performance, application usage, and system configuration that helps System 76 improve its products. The collection is disclosed and can be disabled, but the disclosure is not as prominent as the privacy-first reputation of the Linux ecosystem would suggest it should be. And users who chose Pop! OS without reading the detailed documentation were often surprised to discover the telemetry existed. GNOME, the desktop environment used by default on Ubuntu, Fedora, and many other major distributions, has its own data collection story that is separate from the distribution-level telemetry and that affects users across multiple distributions simultaneously. The GNOME project introduced a metrics collection system designed to help developers understand which features were being used and which were going unnoticed, information that genuinely helps prioritize development effort. The GNOME telemetry system has been a subject of ongoing discussion in the community because GNOME is used by such a large number of Linux users across so many different distributions that decisions about its data collection practices have unusually broad impact. A user who has disabled telemetry at the distribution level may still be subject to GNOME-level data collection if they have not separately addressed that layer of the software stack and the existence of multiple independent telemetry systems at different layers of the Linux software stack is one of the aspects of the current situation that most Linux users are unaware of. The Mozilla Firefox browser, which is the default browser on most major Linux distributions, has its own extensive telemetry system that is worth examining specifically in the Linux context, because many users who switch to Linux for privacy reasons continue to use Firefox without fully understanding what data Firefox collects by default. Firefox telemetry includes information about browser usage patterns, feature adoption, performance metrics, crash reports, and increasingly, information about the web content being accessed through mechanisms that are more sophisticated than simple usage counting. Mozilla has financial incentives to collect this data because it helps the organization demonstrate the value of its browser to potential commercial partners, and because it helps guide product development in directions that maintain user engagement. The data collection is disclosed and can be reduced through privacy settings, but the default configuration collects substantially more than most users who think of Firefox as a privacy-respecting browser are aware of. The Snap package system, which Canonical has been pushing as the primary way to install applications on Ubuntu and its derivatives, introduces a distinct and particularly important privacy concern that goes beyond simple telemetry. Snap packages run in a confined environment that is managed by Snapcraft, Canonical's Snap infrastructure, and that requires communication with Canonical's Snap Store servers for package installation, updates, and in some cases, package operation. This means that every Snap installation generates network traffic to Canonical's servers that includes information about which packages are being installed when updates are requested, and certain system identifiers that allow Canonical to track installation patterns over time. Unlike traditional package management systems, where packages can be installed from local repositories without any communication with a central server, the Snap system's architecture makes some level of communication with Canonical's infrastructure unavoidable for users who use Snaps. For users who are trying to minimize the data they share with any single organization, the Snap system's architectural dependence on Canonical's infrastructure is a meaningful privacy concern that is distinct from and in addition to any explicit telemetry system. The Flatpak package system, which is used on Fedora and many other distributions as an alternative to or complement of the distribution's native package manager, has its own privacy implications that are less discussed than the Snap controversy, but worth understanding. Flatpak itself is a more decentralized system than Snap, with packages available from multiple repositories rather than a single corporate-controlled store. But the dominant Flatpak repository, FlatHub, collects download statistics and usage data that is less granular than individual user tracking, but that nonetheless represents data collection that users of Flatpak applications are contributing to when they install and update applications. The FlatHub data collection is arguably benign in scope and is used for legitimate purposes, like helping developers understand the reach of their applications. But it is another layer of data collection that Linux users who think of their system as a no-tracking environment need to be aware of. The Linux kernel itself, the foundational layer that sits beneath all of these applications and distribution-level systems, has historically been the one component of the Linux stack that was definitively free of any data collection or telemetry. The kernel does not phone home. The kernel does not report to any central server. The kernel runs on your hardware and communicates only with the systems that you explicitly direct it to communicate with. This remains true in 2025, and it is an important anchor for understanding the Linux privacy situation because it means that the tracking occurring in the Linux ecosystem is occurring at layers above the kernel rather than in the foundational operating system itself. But this distinction, while technically accurate, provides less practical reassurance than it might seem, because the layers above the kernel, the distribution infrastructure, the desktop environment, the default applications, the package management systems, are the layers that most users interact with and that determine most of what data leaves their systems. The corporate influence on Linux distributions is the underlying structural force that is driving the telemetry expansion. And understanding this structural force is essential for understanding why the tracking is happening now and why it is likely to continue expanding rather than reversing. The major Linux distributions are no longer primarily community volunteer projects. They are products maintained by companies that have business models, investors or donors to satisfy, and competitive pressures that require demonstrating value and making resource allocation decisions efficiently. Canonical needs to justify its Linux investments to its ownership. Red Hat, now part of IBM, needs to demonstrate the value of its community distribution in terms that justify the engineering resources devoted to it. System 76 needs to understand its hardware performance to compete as a hardware manufacturer. These are legitimate business pressures, and they drive legitimate desires to collect data that helps make better decisions. But they also create an environment where user privacy interests compete with organizational interests in ways that organizational interests have structural advantages in winning over time. The way to understand the current situation clearly is to recognize that the Linux ecosystem has not been captured by surveillance capitalism in the way that Windows and Android have been captured. The tracking happening in Linux distributions is qualitatively different from the tracking that characterizes the major proprietary operating systems. It is less comprehensive, less commercially motivated in the most invasive directions, more subject to community oversight, and more controllable by informed users. But the qualitative difference does not make the tracking absent, and the trajectory of that tracking, expanding scope, more default-on implementations, more organizational dependencies on collected data, is moving in the wrong direction from a user privacy perspective, even if it is starting from a much better baseline than the proprietary alternatives. What you can actually do about this situation right now is not complicated, but it requires taking deliberate action rather than assuming that choosing Linux automatically protects your privacy. The first and most important step is to audit the telemetry settings of your current distribution immediately after reading this. Every major distribution that has telemetry also has a way to disable it, and finding and using that way is the most direct action available. On Ubuntu, the privacy settings in the system settings application include controls for data collection that go beyond the installation time option. On Fedora, the metric system can be addressed through the appropriate configuration settings. On distributions using GNOME, the genome privacy settings offer control over what the desktop environment reports. On systems using Firefox, the About preferences, Hash Privacy page offers extensive controls for reducing what the browser reports to Mozilla. The choice of distribution matters enormously for users who take Linux privacy seriously. Distributions like Debian, which is the upstream for Ubuntu, but has its own separate release process, and community governance have historically been more conservative about adding telemetry and more resistant to corporate influence on their default configurations. Arch Linux, which requires users to build their system from components rather than accepting a pre-configured default, gives users complete control over what is installed and therefore complete control over what telemetry systems exist on their system. Void Linux, Gentoo, and other community distributions that maintain stronger independence from corporate influence are worth considering for users who prioritize privacy above distribution convenience and polish. The trade-off is real and worth acknowledging honestly. Distributions that collect more data are often more polished, better supported on new hardware, and easier for new users to set up and use. The privacy cost is real. So is the convenience benefit. Making that trade-off consciously and informedly is what this article is designed to enable. The broader lesson of why Linux is tracking you now is not that Linux has become the enemy. It is that privacy on any computing platform requires active, ongoing attention rather than a one-time choice of operating system. The choice of Linux over Windows or macOS is still a meaningful privacy choice because the baseline data collection in Linux is genuinely less invasive and more controllable than the baseline and the major proprietary alternatives. But that choice is not sufficient on its own. The Linux ecosystem is evolving under pressures that push toward more data collection, and users who are not paying attention to that evolution will find themselves on a platform that is tracking them in ways they did not anticipate or consent to, even though they made the switch to Linux specifically to avoid being tracked. Know what is on your system. Know what it is reporting. Know how to turn off what you do not want running. That is what being a Linux user has always meant at its best. And it is what being a Linux user requires more than ever right now.